Okay, in this video, we're going to go ahead and continue Unit 2 with Section 2.3, Polynomial and Synthetic Division. So for most of this video, we're going to go ahead and focus on the long division part because that's the one that requires a little bit more work. And we're going to go ahead and use something called the division algorithm. Okay, so this is in your textbook, but we just kind of want to write it here so we know kind of how it works. It says if f of x and d of x are polynomials such that d of x is not equal to 0, okay, and the degree of d is less than or equal to the degree of f, okay, so this one is going to be, this one has a smaller degree than this one, then there exists a unique polynomial q of x and r of x such that this is true. In other words, we can have our bigger degree polynomial here equal to the smaller one times some number or some other polynomial, so in some cases, plus a remainder if it's not evenly, it doesn't go evenly into this guy. This is also known as the division algorithm. So the dividend is the number that, or polynomial, that we divide into. The divisor is the one on the outside. The quotient is the answer you get after you divide, and r of x is going to be our remainder, okay? Where r of x is equal to 0, or the degree of r of x is less than the degree of d of x. So this one has to be less than this one, otherwise it would divide one more time into that, okay? Or multiple times, depending on what this is. I'm going to show you with an example exactly what I mean here, okay? If the remainder of this is 0, that means that this polynomial or divisor divides evenly into f of x. Let's go ahead and do a very simple example of what all this jargon means, okay? Example 1, this is a simple numerical example. It's not a polynomial, it's just a two numbers that I'm going to use to show you how this algorithm works. Okay, so we're going to divide 23 by 4. So just like in olden days, okay, long time ago, used to have this little box where you would put this number on the inside. So that's going to be our dividend. So 23 goes in here. And you're going to divide it by something on the outside, which is our 4 in this case. So 4 is the divisor. Okay. When we divide 4 into 23, we know that 4 goes into 23 5 times at least. Okay. Then we multiply 5 times 4 is going to give us 20. And then we subtract and we get a remainder of 3. Okay, so simple division from back in your elementary school days. Okay, so and you notice I went ahead and color coded everything. We're going to go ahead and write this the way I have it up here using the division algorithm. So according to my division algorithm, the dividend is equal to the divisor times the quotient plus the remainder. Okay, so I'm going to be referencing this so you can look at it on your own notes. So 23, okay, is equal to my divisor, so 4, times our quotient, so times 5, okay, plus the remainder. So in this case, our remainder is 3, so plus 3. So what this says is that these two are equal. Okay, so let's see. 4 times 5 is 20, and 20 plus 3 is 23. So this, in fact, checks out. Okay, so this is what the division algorithm is. It's something you already know. We're just kind of putting it a little bit more formally in terms of polynomials. So we're going to go ahead and do the same exact thing, but now we're going to do it with actual polynomials with something a little bit more complicated. And the steps are the same as what we just did here. Okay, you divide into the dividend. Okay, you multiply, you bring this one down, subtract, and if there's more terms over here, usually you start bringing them down, okay? So keep that in mind for the next example. Here we go. Here's the more difficult one. And you may have done this before. Some Algebra 2 classes do cover this, okay? So before we go into the actual example, I want to show you a different way of writing that same algorithm up here. So we have our, remember our divisor, I'm sorry, our dividend, I keep saying this backwards. Our dividend is equal to the divisor times the quotient plus the remainder. So I'm going to write this like this instead. And I'm just going to show you why that's allowed. Okay, so if I divide all of these terms, okay, by d of x, like so, okay, this is canceled out, or I shouldn't say cancel, it becomes 1, so I can cross it out, okay? And we're left with f of x over d of x, so that's this one. Q of x is by itself, plus the remainder over the divisor. Okay, so we're going to actually be using this one for our what's called long division. Okay, so we're going to use this format for long division. All right, so before I go in, well, I'll show you the example. Maybe you can write it while I explain a couple of things. So what do we even need long division for? Long division is used when we're trying to find the other factors of a polynomial given one factor or given a zero. So for example, we know that, say, for instance, x squared minus 4, okay, I'm just going to pick an easy one, x squared minus 4 is equal to x minus 2 times x plus 2. So if I was given one of those, I could divide x squared minus 4 by that factor, and if I follow my steps correctly, I will come up with the other factor, okay? Now, it might seem kind of easy for that one, but, you know, when you have multiple terms like x cubed, x to the fourth, the factoring gets a little bit more difficult. So that's why we use long division, or another method that I'm going to show you in a bit too. So it's kind of like another way of getting those factors, and we're hoping that the factors go in evenly. If they don't go in evenly, then we have a remainder, like the one that's kind of written here. Okay, so there's a bit of a backstory there. Let's go ahead and jump into an example now. So we have example number 2. And this one actually gives us the answer. I wanted to give us the answer just so you can see the format and how the steps apply. It says divide x squared plus 3x plus 5 by x plus 1 to show that this part right here is true. So just kind of looking back at our format here, we have our dividend, divisor, okay, quotient, remainder, so the 3 is the remainder, and then there's the divisor again, okay? So we're going to use long division to get this answer, and I'm going to show you all the steps here on the side. So let's go ahead and scroll down. I'm going to go ahead and move this just a bit. There are some steps I would like you to write down because you should know how to divide, but when it comes to polynomials, it gets a little more complicated because of all the x's, okay? So we're going to start by doing step number 1. We're going to divide the first term of the divisor into the first term of the dividend. So I'm just going to write that out over here. So in my little box here, I'm going to put my dividend, x squared plus 3x plus 5, okay? And my divisor on the outside, x plus 1. Please forgive me if I keep switching these. I have a tendency of doing that for some reason. But this is the dividend, this is the divisor, okay? It says divide the first term of divisor into first term of the dividend. So that means x squared divided by x. That's what this is saying. The first term divided by the first term. If we divide this, x squared divided by x is just x. Remember when you're doing you're dividing with the same base, you actually subtract the exponents, okay? So I'm going to have x on the top up here. And let me try to let me match my colors real quick. So I have the quotient in purple. So let me keep it in purple. All right, so this is going to be part of my quotient up here. Step number 2 is to multiply the answer by the divisor. So my answer is x. So I'm going to multiply x times my divisor, x plus 1. And that's going to give me x squared plus x. And that's what goes on the next line. So it's just like division, where you find an answer, you multiply, and you bring it down, okay? And then we're going to go ahead and subtract for step number 3. So step number 3 is to subtract. For this one, you want to be a little bit careful because when you subtract, you're subtracting this whole thing here. So in actuality, you're kind of changing the signs, okay? So for the subtract part here, you're thinking x squared plus 3x minus x squared minus x, if that makes any sense. Okay, so these are going to be 0. 3x minus x is 2x. Okay, if you would like to distribute the negative, you can. Just make sure you keep track of where your signs are. Okay, I tend to distribute, I tend to do this. So negative and negative. Like I said, you got to keep track of which one you're using. Okay, then step number 4 is to bring down the next term of the dividend. So in this case, it would be the 5. So I'm just going to put 5 here in parentheses. Okay, number 5, repeat. So now we're going to go ahead and go back to step 1, divide the first term of the divisor into the first term of the dividend. In the sense of repeating, this right here becomes our new, I guess you could say, dividend. It's not really the dividend, but in the sense of repeating the process, we're going to go ahead and divide this guy into this guy. So this would be like saying 2x divided by x. So again, first term divided by the first term. And that's going to just give us 2. Okay, so the 2 goes on the top. It's positive 2, so plus 2. Okay, and we're back to step 2, where we multiply the answers. Now we're going to multiply 2. If you want, you can put kind of like a comma here. 2 times x plus 1 is next. So think of it like that. 2 times x is 2x. 2 times 1 is positive 2. We move on to step 3. I'm not going to write the stuff over here anymore. I'm just going to go through it. So we subtract. Okay, so this becomes negative, that becomes negative. That's gone. 5 minus 2 is 3. Okay, and we're pretty much done. I'm going to go ahead and just show you now how this relates to what I had up here. Okay, so according to that, I had, and again, I'm just using the colors I had earlier. I had the dividend. So my dividend here is x squared plus 3x plus 5. Okay, divided by my divisor. So my divisor was x plus 1. Move that down just a little bit. Okay, and this is equal to the quotient, in this case, x plus 2, plus whatever the remainder is. In this case, my remainder was that 3. So plus 3 divided by, again, I'm just going off of this pattern here. Oh, r divided by the divisor, okay? So divided by my divisor of x plus 1. And that would be the answer for this one. And now we just proved it by using long division. Okay. Since we have a remainder, that means that this one does not go in evenly. In other words, x plus 2 is not necessarily a factor because we're going to have a little bit left over on the graph. Okay. But if you were to graph this, so if you were to graph this in the calculator and graph this in the calculator, you would see that they're both going to be the exact same function. Okay. So let's go ahead and try another one that's a little bit more difficult now. Or a lot more difficult. Don't remember what I put here. Example number 3. Okay. So this is going to go a little bit more into the zeros and the factors. It says, given the polynomial f of x is equal to all of this, okay, and one of the zeros, x equals 2, find the other factors and zeros. So I started the setup for you here. I went ahead and said, well, we're going to go ahead and take the bigger polynomial and divide it by x minus 2. This is x minus 2 because the factor The factor is coming off of this right here. Since my 0 is x equals 2, then the factor has to be the opposite, right? Because it's like going backwards. It would be like taking the 2 back over to this side and setting it equal to 0. So my factor is usually going to be something a little bit different than the 0, usually just opposite signs, okay? So just keep that in mind. We're going to go ahead and go through our steps again. I'm not going to write them out this way. I'm just going to kind of go through it. So let's go ahead and set that up. I have a whole page for this one because I don't know how long it's going to take us. So let's see. We have 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2. And I believe this one should go in evenly. So let's see. If it goes in evenly, that means that we're going to have a remainder of 0. Okay? So first, we're going to go ahead and divide our first term into our first term. So if you have to do some sight work, by all means, do the sight work. This is like saying 6x cubed divided by x. Okay? Which is going to give us 6x squared. So the first part right here is 6x squared. And we got that from here in case you're not sure where this is coming from. Okay. Then we're going to multiply that. So we're going to multiply this times my divisor. So that should give us 6x cubed minus 12x squared. And then we're going to subtract. Okay, so if you do this correctly, usually that first one will cross out because that's what division usually will do, so you can kind of get the rest of it, okay? So from here, we're going to subtract, and I'll go ahead and do like a color change here, that way we know for sure which sign we're using. So this is going to become positive, and that's going to become negative, okay? So that one is 0. And then we have negative 19 x squared plus 12x squared, which is going to be, let's see, negative 19 plus 12 is going to give me negative 7x squared. Okay, bring down the next term, so plus 16x, and then we do the process all over again. Okay, some people like to bring down the whole thing. I do one at a time because I feel it's a little bit more structured, but that's up to you. Okay. So now it goes all over again. So we're going 7x squared divided by x. So if you want the side work right here, we can do it over here. Negative 7x squared divided by x is going to give us negative 7x. Okay, so that's going to be the next term in the quotient part. So minus 7x. Okay, and that's coming from right here. And then we multiply. So just like before, negative 7x times all of this is going to give us negative 7x squared. Negative 7x times negative 2 is positive 14x. Okay. We subtract. So since I'm subtracting, these signs are going to change. That becomes positive. That becomes negative. This one is 0. Okay. 16x minus 14x is going to give me 2x. So 2x, hold this down just a little bit. Bring down the last term, so minus 4. Okay, and we do it all over again. So 2x divided by x. Again, we need the side work. Here it is. It's just going to be 2. Okay, so positive 2 goes over here on the end, and that's coming from right here. And then we multiply. 2 times x is going to be 2x. 2 times negative 2 is going to be negative 4. We subtract, which means the signs are going to change. That's negative and that's positive. They both are gone because we now have a remainder of 0. Okay, So this one came out evenly because the remainder is 0. So let me go ahead and write it out first, and then we'll go ahead and do a little bit more with this one because we can, okay? So in answer to our division, okay, we're going to have our problem to begin with. So 6x cubed minus 19x squared plus 16x minus 4 divided by the divisor x minus 2. Oh, I cannot see what I'm doing. There we go. Okay, is equal to the quotient, which is this right here. So 6x squared minus 7x plus 2, okay? And it's supposed to be plus the remainder over the divisor. But since we don't have a remainder, that's pretty much it. So if you were to graph this and then graph this in a separate y equals, they would coincide. It'd be the same thing, okay? So let's see what this means. This means that this right here is a factor, quote unquote, of this. So we're going to see if we can factor further to find the other zeros. So we're going to factor further to find zeros, okay? So 6x squared minus 7x plus 2. If I try to factor this out, remember here you can use your multiple different methods. You can use the guess and check. You can use slide and divide. You can do factoring by grouping, okay? I'm going to go ahead and do guess and check just because I feel for me right now it's a little bit easier. So I'm going to try 2x and 3x. Because I know that 6 has to be 2 times 3 or 6 times 1, but since my 2 only has a few factors, 2 is just 1 times 2, I'm going to go with the smaller numbers and see what works. Let me see. I'm going to do this kind of in my head here. I'm going to say -1 and -2. So let's check that real quick. 3x times 2x is 6x squared, so we're good to go there. -2 times 2x will give me -4x, okay? 3 times 1 is going to give me -3x. So if you add those, you get that -7x, and then -2 times -1 is +2. So these factors are good, okay? And again, if you can't do it this way, you can always use slide and divide, and that's perfectly fine, okay? So these are my factors. The other factors, okay, I should say other factors. We're going to find the zeros now by setting them equal to 0. So 3x minus 2 equals 0. 2x minus 1 equals 0, and we just solve. So I'm going to do this pretty quickly because this should be second nature right now. So x is equal to 2/3. That's one of the zeros. Okay, this one, let's see, 2x equals 1. X equals 1/2 is the other one. Okay, so these are my other zeros. But remember that we had a 0 from the way beginning, right? We had this, remember, this is a factor right here. So if I wanted to graph this, I actually could without a graphic calculator. Okay, I know that I have a 0. Let's go ahead and put 1 right here because it's these are small numbers, right? We have 2/3, which is about 0.67. So I'm going to say that that one is about right here. Let's say this is 2/3. Okay. And then we have 1/2, which is half of this. So I'm going to say 1/2 is about right here. Okay, and then I know that x minus 2 is a factor. So this is from, we could say previously, because we already have this information. Okay, x minus 2 is a factor, which means that x equals 2 is a 0. Okay, so 2 is going to be somewhere over here. Oh, it's kind of crooked, sorry. So there's my 2. Okay, so there are my zeros. Okay, and based on what I know from before, my prior knowledge, okay, I know that this is a cubic function, so it's going to be probably something like that, okay, something like this. It's positive So the end behavior is up on this side and down on this side. So let's go ahead and check that out here. So there's down, there's up, and we just fill in the missing gaps, something like that maybe. And you'll see if you graph it, it's a pretty decent estimate. Okay, so there we go. We used long division to find the other missing factors. Okay, but remember, to get the factors first, we had to divide. We got this new polynomial. We factored it because there was no remainder, so we were able to factor it. And then we set these equal to 0 to find all the missing zeros, plotted them all, and there we go. Okay, let's go ahead and we're going to do one more of these. And then we're going to do synthetic division, which is my favorite because I feel like it's so much easier. Okay, so we're going to divide x cubed minus 2x squared minus 9 by x minus 3. For this one, I'm not going to do the graph and everything else. I just want to do the division. Okay, couple things on this one. The polynomials must be in descending order. So that means that you have to have the highest exponent here going down that way. Same thing with the divisor. And if you're missing some, you're going to use placeholders for those missing terms. You'll see what I mean in just a. All right, so let's go ahead and begin. I'm going to go ahead and start by rewriting this with the missing terms. We have our x cubed, we have our x squared, but notice that we're missing the x. Usually we have another term here, the x, okay? So that's going to look like the following. I'm going to rewrite it as x cubed minus 2x squared plus 0x minus 9. And we're allowed to do that because 0 times anything is 0. So it's really not changing anything. We're just putting it as a placeholder. Okay, so let's start our division by using this one now. So I'm going to have x cubed minus 2x squared plus 0x minus 9 divided by x minus 3. Okay, so same thing as before. We're going to do x cubed divided by x, which is x squared. That goes on top. Okay, and then we multiply. So x squared times x minus cubed is going to give us, let's see, x cubed minus 3x squared. We subtract. So this will become negative, and this one's going to become positive. So that one is gone. Negative 2x squared plus 3x squared is positive x squared. Bring down the 0x. Okay, even though we don't really need it, it's all right. We're going to do the same thing all over again. So x squared divided by x is going to give us 1x. So plus x. Okay, multiply this x times x minus 3 is x squared minus 3x. Okay, and then we subtract just like we did before. So that one becomes negative, that one becomes positive. This one is gone. 0 plus 3x is, well, 3x. Okay. Bring down the last term. And then we divide one more time. So 3x divided by x is just 3. And I believe it's positive 3. Okay. 3 times all of this is going to be 3x minus 9. So it came out nice and neat for us because we should know kind of just by looking at it that when we subtract this, okay, all the signs are going to flip. So everything is gone and we're left with a remainder of 0. Okay, so that means that this one goes in nice and neat. Okay, and can we factor that one? Let me see. No, we can't factor this one. This one's going to be a quadratic formula problem. Because if you look, the factors are 3 and 1. There's no way to get a 1. So we're going to go ahead and just leave it so we don't make the video too long. But let's go ahead and just rewrite this in our form here. So we're going to have, make this a little bit more spacious. There you go. So x cubed minus 2x squared minus 9, okay, divided by x minus 3, okay, is going to be equal to this up here. So x squared plus x plus 3 plus no remainder because the remainder was 0, okay? And I guess we could make a note here that x cannot equal to 3 because we can't divide by 0 here. But we're going to leave it just like that for now just because all I really want from you is this answer here. Okay, and that is it for long division. Now, really brief, this one shouldn't take too long, the next one. It's synthetic division. You might have to pause here just to copy this process. I hope you've seen this before. If not, you're probably, I mean, I don't know about you, but I like this method because I feel it's a lot simpler than long division. This is another way of doing division with polynomials when one of the zeros is known. So the ones we just did before, we were given at least a factor or a zero that allowed us to divide in the first place, okay? This craziness right here is the method. So what happens is we are given a polynomial. It does have to be in descending order, just like the long division. And x minus k is one of the factors, or, k, whatever they decide to give you. You started off by getting the 0. So k here is the 0, not the factor, it's the 0. You take all of the coefficients, you list them out like this, okay? And then you follow this kind of like zigzag pattern where the first one just comes straight down. The next one is going to be your 0 times this value, okay? And then you subtract these, get a new answer. You bring this over again. I guess I can do an arrow like that if you would like, just so we can see. So the k gets multiplied here, okay? And then we bring it up, subtraction, the k gets multiplied. Oh wait, I'm sorry. Yes, and then it goes back up, subtraction, remainder. Okay, so it works like that. We subtract the vertical column, so except for the first one. We subtract these ones, and we multiply the answer, which are the circles, okay, by k until we get to the end. When we're finished with this whole thing becomes the coefficients for the quotient, and it's always 1 degree less. I should probably make a note of that. I'll just put it right here. 1 degree less. Okay, so if this was x cubed, this one should be x squared. All right, we're going to go right into an example because this one is best shown with an example, as are most math problems. So we're going to start with our polynomial. It's already in descending order, so we're okay with that. And our factor here is x plus 2. Okay, so first of all, the 0 is going to be x equals negative 2. Remember, we have to set this equal to 0 to solve, so it's negative 2. So here in my little box, I'm going to hold on to negative 2. Okay, then I'm going to look at all my coefficients in descending order. So 5, 8, negative 1. There's a 1 here, so if you want to put that 1, you can, and 6. And those numbers go on top. So 5, 8, negative 1, and 6. Okay, and then we just start the division. So we put a line here, we drop down the first one, so bringing this down is just a 5, okay? And then we bring our 0 value and multiply this here and bring it up. So negative 2 times 5 is negative 10, okay? We combine these two, 8 minus 10 is going to be negative 2, okay? We do it all over again. So multiply, negative 2 times negative 2 is positive 4. Combine these two. I guess I should say combine, not subtract, huh? But it works fine either way. Negative 1 plus 4. Oh, where is my, can't find my purple here. Well, that's okay. I'll just stick with this. It's fine. So it's going to give me 3, okay? And then we multiply. So negative 2 times 3, it comes up. Here's my 6, okay? Oh, negative 6, my bad, sorry. Negative 2 times 3 is negative 6. Combine these two, and that gives me a 0, okay? If you want to go ahead and make that little, I put subtract because the text says subtract, but I'm just going to say combine because I think that makes more sense to me personally. You can leave subtract if you want. Anyway, so we're almost done. We're going to go ahead and rewrite this now as a quadratic. So here's how this part works. A quadratic, because since the degree was 3, 1 degree less than 3 is 2. So this would be 5x squared minus 2x plus 3. And this one means there is no remainder. Okay? If there was a remainder, you would just write the remainder r divided by your divisor, just like we did before, okay? If remainder. This is like a side note, okay? And that would just be your divisor. So same as before. And then from here, if you could factor, you would factor, okay? So this one, all right, yeah, this one cannot be factored, so we're pretty much done here. And this would be your answer for this one, okay? So this divided by that is equal to this. So we want to write it officially. We say 5x cubed plus 8x squared plus x, well, minus x, I'm sorry, minus x plus 6 divided by x plus 2 is equal to all of this, 5x squared minus 2x plus 3. So you can see that it follows the same format as long division, okay? All right, one final one. I know this video is kind of long, sorry. Believe it or not, there is still more to this one, but we'll do that in a separate video. Just one final example, just so in case you do see one like this, you know what to do. This is a super simple one, but notice that we're missing a term. So just like with long division, we have to kind of rewrite this. So I'm going to do my rewrite with all the terms. So x squared plus 0x minus 9. 0x is the missing term, okay? So we're going to go ahead and do our synthetic division. My 0 here, okay, is going to be x equals 3. Because if you set that equal to 0 and you solve, you get 3. Okay, so 3, okay. My coefficients for this one are, or for this one I should say, are going to be 1, 0, negative 9. We start the process, so bring down the 1, multiply, bring up, combine, multiply, oh, too far. Multiply, bring up, so it's 9, combine, and we're done. Since this is x squared, this one's going to start at x. So from here, we have x plus 3 is our answer. And it's actually just a factor. And this seems to make sense to me because if we were to rewrite this, x squared minus 9 divided by x minus 3, okay, well, the only other factor for this is x plus 3, so this definitely checks out. And if you don't know what I mean, you can always check it this way too. If I were to multiply both of these sides by x minus 3, let me box this up first. Okay, if I were to multiply both sides by x plus 3, you would get x squared minus 9 equals x plus 3 times x minus 3, which are indeed the factors of x squared minus 9. Okay? And that is it for this video, long division and synthetic division.